Solve the following inequality. Here we have a quadratic inequality involving only one variable. To solve this, we will express the inequality in standard form. We will then determine the solutions to the corresponding equation. These solutions to the equation will correspond to the x-intercepts of the corresponding quadratic function. Based on the direction of opening of the quadratic function and the inequality symbol, we can then determine which values of x correspond to the solution. First, by subtracting 2x and adding 5 to both sides of the inequality, we can put it into standard form, leaving a 0 on the right-hand side. We will then solve the corresponding equation. In order to solve this equation, I will divide both sides by -1 so that the term beside the x squared is positive. In order to solve this, we will have to use the quadratic formula. Substituting numbers into the formula and then simplifying what's inside the square root, the discriminant is 44. Note that the square root of 44 can be simplified. It can become root 4 times root 11 or 2 root 11, giving us -2 plus or minus 2 root 11 over 4. We can then cancel out a 2 on the numerator and denominator, giving x equals -1 minus root 11 over 2. This corresponds to -2.16, and then we also have -1 plus root 11 over 2. This corresponds to approximately 1.16. Looking at the function now, we have x-intercepts at approximately -2.16 and 1.16. The parabola opens downwards since the value of a is -2. We then have to look at the original inequality. Note here we're looking at where the function is greater than or equal to 0. This corresponds to y values above the x-axis. We can then say that between -2.16 and 1.16 are the x values corresponding to the solution. Note that for the original inequality, it's a greater than or equal to, so we have to include these x-intercepts in our solution. We then have -1 minus root 11 over 2, less than or equal to x, less than or equal to -1 plus root 11 over 2.